hepatic clearance. As you know, clearance is probably our most important factor when we're considering dosing regimen changes, so we want to make sure we understand it really well. Total body clearance is going to be equal to all the different organs of clearance. Last week we focused on hepatic clearance, and this week we're going to jump into renal clearance. So how does the kidney actually clear drug, and what determines the clearance of a drug that is cleared by the kidneys? All right, I'm not going to read through all these. You guys can do that on your own. As I said, usually the two organs of clearance that are involved in most drug clearance are the kidneys and the liver. So we have total body clearance being equal to hepatic clearance plus renal clearance. And here's how, if we know the fraction that is excreted unchanged in the urine, which we symbolize as Fe, F little e, we can determine renal clearance if we multiply our total body clearance by the fraction that is excreted unchanged in the urine, because drug that is unchanged is parent drug. Therefore, it has not been metabolized by the liver. So whatever is not being metabolized is going to have to be excreted in the urine. So whatever is excreted unchanged in the urine as the parent drug, not metabolized, that's going to be renal clearance. I mean, most of the drugs go out in the urine, but they might go out as a metabolite. If they go out as a metabolite, they've already been cleared by the liver by being changed into something new, being metabolized. I hope that's clear. So if we know that, so the Fe, the fraction that is excreted unchanged in the urine, if it is 0, that means we're going to assume that it's totally cleared by the liver, because none of the drug is coming into the urine as parent drug. It's all being metabolized, therefore it's all cleared by the liver. If Fe is 1, that means 100% of the drug is being found in the urine unchanged, which means 100% of it is cleared by the kidney. Now, I don't want you to worry about this too much, but I want you to realize that there's renal blood flow that's coming in to the nephron. Here's our glomerulus, and then here's our nephron, right? So we have drug coming into the kidney. So renal plasma flow is about 20 to 25% of our cardiac output. Our cardiac output is 1.2 to 1.5 liters per minute. So remember, with any clearance, it's going to be Q times E. So we need to understand the blood flows here, right? The renal blood flow is 20 to 25% of this. And then our renal plasma, so if we did the math, I'm not going to just because it's not that important, but you can do it. The renal plasma flow, remember plasma is blood minus the red blood cells. So you have to consider the hematocrit there. So your renal plasma flow is going to be between 0.66 and 0.83 liters per minute. And our glomerular filtration rate, so our glomerular filtration rate is the blood coming into the glomerulus, is 125 to 150. So we consider it to be 125 mils per minute is our normal average GFR, which is filtration through the blood flow that filters into the glomerulus. And then this is into our tubule. I'm sure you've already had your I hope you've already had your renal physiology. So we've got the glomerulus that's really just a filter as a drug comes into the nephron. So when the drug does come into the nephron, basically what we've got going on is the drug comes in through the glomerulus, which is a filter here. So we've got filtration happening here. This is to keep the big stuff here in the blood, and then we don't want to be letting any proteins or any things that are hard to make. Now this is in the tubule, right? So we've got the blood being filtered into the tubule, and as you move down through the tubule, eventually you're going to make it to the bladder and then out of the body. Obviously this is not really physically how it looks, but we've got here is we're going to call this the proximal tubule, which means closer, right? So this is the proximal tubule, and then this will be the distal tubule. We have three things happening here. The first thing is drug will come in through the blood. It's going to be delivered to the glomerulus, and the blood will either go through here or it won't. The drug will either go through here or it won't. Basically, if a drug is bound to a big honking protein, here's our drug and here's our protein, it's not going to fit through this glomerulus. So only unbound drug will make it through this filter. Well, why would that be? Well, because we don't want we don't want to be peeing proteins out. Protein is really hard to make. It takes a lot of resources. So it would be silly to be peeing that out. We want to, and it's not hurting us. We need protein. So if you have protein going through here, you have something wrong with your glomerulus, don't you? So we want to make sure that we know that if our drug is bound to protein, it's not going to be filtered into the nephron. It's going to stay in the blood. Okay, so that's your first thing, is we've got our filtration. Then the next thing that happens in the proximal tubule is we can have drug added from the blood to the nephron. We can have drug, so if we think of this as the bloodstream, we can have drug move from the blood into the nephron. This is called secretion. And it is an active process. What does an active process mean? It means that it takes energy, and we're going to talk more about that. But drug can be moving from the blood into the urine. So drug is being moved from the blood into the urine in the proximal tubule by tubular secretion. And then as we move through here, what's happening as we move through the nephron? Well, one of the big things that's happening is we are reabsorbing water. Because we don't want to have all of this water go out in the urine. Because again, we need water. Water is important to our bodies. We're, 3/4 water. So we don't want to just be peeing water out all the time. One of the things that I can tell you is, remember filtration clearance. Remember what the GFR is about 125 mils per minute. So about 125 mils per minute of blood is being filtered through that nephron. How much do you think our urine output is? It's about 1 mil per minute. So what's happening big time is water reabsorption. So this is all being concentrated as it moves down the nephron to the bladder. Big time concentration, because we're taking water back into our bodies because we need that water. So what's happening to our drug concentration? If there's drug in here, it's becoming more and more concentrated as it moves through here. So the other thing that happens is we have reabsorption. So drug can be reabsorbed from the nephron, taken out of the nephron, and go back into the blood here in the distal tubule. So we have three processes. Filtration, first the drug has to be filtered. Only free drug can be filtered. Then we can have secretion. This is an active process where drug is being moved from the blood into the urine. And then last but not least, in the distal part of the tubule, we can have reabsorption. So drug will be moving from the urine back into the blood before it goes out in the urine.